Okay, so we're going to be recording for the Alka Seltzer lab. We're going to be recording the masses for column A, B, and C for experiments 2 through 7. I've already done 1 and 8 on the other video you should have watched. You can fill in Y and Z based on the data table on the previous page. You can get all those numbers. If you haven't done that yet, you can just go back and do that later. For now, you're going to want to have your data table out or make one, and you're going to fill in A, B, and C from the numbers I do right now. Then I'm going to let the reaction finish and come back and record D, which is what we need to complete the calculations. Okay, the pink color is caused by universal indicator. I've put universal indicator into the acetic. The acetic acid, of course, is the vinegar. It's been mixed with distilled water in different proportions. Over here it's got more acetic, over here it's got more distilled. The Alka-Seltzer tablets are out. Each one is slightly different in mass. Each one has its own mass. Every flask has its own mass. And what I'm going to do is put them in, and we're going to start with experiment 2. I'm going to make sure this is tared, okay, zeroed. Okay. It doesn't actually ask you for the mass of the flask, but it's good to write that off on maybe on the margin, the mass of the empty flask. Then I'm going to pour in the liquids for experiment 2, get them all in there. Okay, that's the mass of the flask and liquid, that's A. Then what I want to do is get the mass of the tablet, the actual tablet that I'm going to use in this experiment, the actual tablet right there. So this is B, mass of the tablet. Then I am going to get the mass of the total contents, the flask, the liquid, and the tablet all together. This is before the reaction. And then, oh yeah, make sure to write that down. Make sure, oh, did it change slightly? Make sure. Interesting, depending on the position, I get a slightly different reading. Okay, just to make sure, let me take these off. Let me tear it, and then I'm going to put them all back on there. Okay, so that's the one I would use. That's the one right there. That's the number that I would write in for C. Okay, then I'm going to plop it in, and then we'll get D later when this reaction has completed, and I'm going to get it going there, but you can watch the number. It should already begin to drop. Remember, this number is going to get lower. So we expect D to be lower, even though there's conservation of mass. Notice some of the gases are going out. Okay, it's happening very rapidly. Okay, so that's number 2. Now, I'm going to get experiment 3 going. Okay, again, I want to make sure this is really tared. Okay, here is the flask. Okay, here's the flask. Let me write that on the margin. Here's the flask with the liquid in it. All the liquids. That is A, the flask and liquid. This is experiment 3 again. Okay, the tablet I'm going to use in experiment 3 is this one. Right there, the mass of the tablet, column B. Then let's get the mass of everything together, column C. Then I'm just going to plop it in, and the reaction will start. Of course, that should be dropping. That should be dropping, of course, just like all of them should be dropping. Okay, so let this reaction go. That's experiment 3. Experiment 4, you know the drill now. Experiment 5. Very different mass for this particular flask. It's a different kind of flask. Break it. Experiment 6. And finally, experiment 7. The reason I usually record the mass of the flask on the margin is because sometimes things go wrong, and it's always good to know the mass of pretty much everything involved in the experiment. So now I'm going to leave experiment 7 going on here until it's finished, and then I'll come back and I'll get a recording of their final masses after the reaction. Now notice how this one's going down, down, down. So when it stops changing, when they all look like they've stopped changing, I'll just go through and I'll get a mass for each one of these. And those will be what you put in to column D. Then you will subtract C minus D to get column E. And then we got to do some stoichiometry to get to column F. So getting to D is what we're getting our data for. Then the rest is calculations. That's why I drew that line on there. Okay, so I'll come back and I'll get the final data for the masses after the reaction, column D, after the reactions are done. Okay, these are going to be the masses after the reaction, column D, and I believe I've tiered the balance. Let's get experiment number 2. This is the mass after the reaction. It's stopped changing, I believe. That looks like a good one. Experiment 3, the mass after the reaction. I believe it stopped changing. Experiment 4, probably that one. Experiment 5, experiment 6, probably that one. Experiment 7, okay, so now notice that experiment 5 was very different mass because the flask is different, but that'll all come out in the wash. It was the same flask going in and out. So now that you've got column D, you can subtract, write them in, you can subtract C minus D to get E, and that'll be the mass of carbon dioxide that is produced.